Hello, this is Professor White. Today we will talk about how we can solve logarithmic equations. Let's get started. Okay, the question is, you're asked to solve something like this. You have a log on the left and log on the right. It looks like the bases are matching. The only way to solve this is that if the bases are matching, you have logs on both sides. That means these two have to match as well. So this is fairly easy, so you get x equals 3. And plug it back, always check. This is too easy to check, but log of 3 is log of 3. Okay, nothing to it. Now let's go to the next level. You have a log on the left and log on the side, on the other side. The bases are matching, they're both base 8. So that means the insides have to match. Here's one more step. X plus 5 equals 7, subtract 5, you're going to have x equals 2. Always check. Why are you checking? Because the logarithm domain is limited. It has to be a positive number, remember? It cannot be 0. So log, put in here, you get log of 7 equals log of 7. No negative numbers, so no problem. Alright. Let's look at this. Log base 36 of x equals 1/2. Now I don't have logs on both sides. The best thing to do is to use the inverse property. Remember, when I take inverse of a function, I get x. So this is, what is the inverse of logarithm? Exponential, right? Exponential functions are inverses of logarithmic functions. So this is base 36. So this is what you do. You take 36 to the of the left, 36 to the of the right. And what will happen, these two? They'll go away. You're going to end up with x, 36 to the 1/2. What the heck is that? Square root of 36, which is 6. Always check. Check with your original equation. What is that? Log 36 of 6. What is that? Log, I know that these two have to match. 6 is square root of 36, right? Square root of 36, which is that. Alright, it is checking out. That is good. I don't have any negatives or anything. So here's one procedure. When you had exponential equations, remember you take the ln of both sides, because ln and logarithmic equations are inverses. And then when you have a logarithmic equation, you take exponents of both sides. Make sure that the bases match, and that's it. Alright, let's look at this problem. Okay. Okay, I have log base 2, or r plus 4 to the second power equals 4. Okay, what can I do? This is log base 2. Take 2 to the of both sides. Okay, these two will go. So you have r plus 4 squared equals 2 to the 4. 2 to the 4 is 16. Now I'm going to have to kind of open this up. You have r squared plus 8r plus 16 equals 16. Oh, watch. The 16s will go. You're going to end up with r squared plus 8r equals 0. How do I do that? Factor, no problem. r plus 8. Set each factor to 0. r equals 0. r plus 8 equals 0. That means r equals negative 8. This doesn't mean that negative 8 is automatically out. You just have to go back to your original equation. Let's look in there. Make sure you don't get a negative. So you have log base 2. Let's check 0 first. 0 plus 4 squared. Is that 4? So that means log 2, 4 squared, that's 16, which is 2 to the 4th. Yeah, that works. So r equals 0 is a perfectly good solution. Now let's go to the next phase. I'm going to check. I'm going to check what happens with r equals -8. Check. Well, let's go to the original equation. Log base 2 of -8 plus 4 squared. All right? Let's see. Log base 2, -8 plus 4, that's -4 squared, which is log base 2. What's 4 squared? That's 16, which is log base 2. 16 is to the 4th. Very good. Look what happened. R equals -8 also worked. So your solutions are 0 and -8. So be careful. When you get a negative number, it doesn't mean that you automatically get rid of it. You always have to go back and make sure that it works or it doesn't work. Okay. Let's do some a little bit more complex. Let's use the properties of logarithms. So when you have a plus, that means you can add. So this means log 3x minus 5 equals log 2x. Alright, I can actually go, since the logs match, I will match the insides. 3x minus 15 equals 2x. Subtract 2x. You'll get 3x minus, x minus 15 equals 0. X equals 15. Always go back and make sure that this doesn't give you negative stuff. 15 minus 5. Check. Log 15 minus 5 plus log 3. Is that log 30? Alright, what is that? 15 minus 5, that's 10. This is 3. And plus, that means log of 30. Is that log of 30? Yes. When you check, you actually got x equals 15. It worked in here. Let's look at this one. Log x minus 7 minus log x plus 3, minus log x plus 3 equals log 6. Well, what does that mean? I'm going to put the left-hand side, log x minus 7 over x plus 3 equals log 6. Logs match, that means the insides have to match. X minus 7 over x plus 3 equals 6. Do crisscross, you have x minus 7 equals 6x plus 18. Let's subtract x. So you have 5x. And let's subtract 18. You have negative 25 equals 5x, which is x equals negative 5. Now let's go check. When you check, look what happens. Log x is negative 5, negative 7. We have a problem right here. You're supposed to take log of a negative number, and that's not going to work. So, since this is the only one that I found out, the answer is no solution. Alright, very good. It doesn't mean that when you have a situation with the negative logs in there and it doesn't work. So let's look at this problem. There's a negative, that means log base 7, this means x plus 6 over x minus 3 equals log base 7 of 4. Since the logs and the bases match, that means the insides have to match. So you go and you do just like you did before. And crisscross, x plus 6 equals 4x minus 12. Subtract x, 6 equals 3x minus 12. Add 12. You have 3x equals 18, x equals 6. Alright, again, just like before, you're supposed to check. What am I going to check? I'm going to check the original equation. Check. Here's my original equation. Log base 7, x plus 6 minus log base 7, x minus 3, log base 7, 4. Put 6, log base 7, 6 plus 6, 12, minus log base 7, 6 minus 3, 3, log base 7, 4. There's minus, that means log base 7, 12 over 3, log base 7, 4, 12 divided by 3, that's 4, 4, 4 log 7. Yeah, it looks like it's working. So we did the same exact steps, but in the previous example, it did not work, and for this one, it did work. So you always have to check. Make sure you do check. I cannot just tell you enough.